Good day everyone and welcome back to the channel. We're going to get started on building this battery box. I've just put all the amplifier stuff off to the back and I've got the battery stuff here. I do have also another two 9-volt batteries that are brand new, fully charged, but I'm not going to be using these two. It's not because they're a different brand, that really doesn't matter. It's just because I got another packet of these out in the kitchen, so I'll go grab that. We'll have 4 brand new batteries the same. I was missing one battery clip when I went to my drawers. I only had 3 battery clips, but I had an old 9-volt battery that was flat, so I cut the top out of it. I'm just going to have to take the focus off for a minute. I cut the top out of it, like so, and soldered some wires to it and heat shrunk it and cut around the heat shrunk. So I've made the 4th battery clip. So we've got 4 battery clips. Like I said, this is going to be running on charge modules and lithium ion cells. I'll probably use little, not 18650s, but something like one of these sort of cells, because as I said in the last video, it's going to be 4 cells times 2 for 4 cells for the positive rails and 4 for the negative. So probably 4 cells about this big in series, because 2 lots of that plus the circuit board and the front panel stuff will fit perfectly in this little box. So anyway, for now, like I said, it's just going to be these. In a couple of weeks, when I get a couple of, I'm going to order 2 4S BMS modules basically, or like an 8S fuel supply balanced. I'll work it out. I'll have it done so that it charges off the one port, but we've got a fuel supply, but the batteries are still balanced. Don't worry, I'll work that out. I'm pretty good at making up battery packs and all that sort of thing. So that's what's going to happen with that. I'm going to go off now, make up a schematic, come back with the schematic. I'm not going to even really bother making a schematic so much as I'm going to make basically the circuit exactly how it's going to be laid out on the board. I'm just going to go for it all in the one go with pencil and paper and an eraser, and I'll come back and show you the layout, and then I'll go and draw the layout on the board, and then we'll etch the board. So I'll be back soon. Alright, so I've just drawn a basic schematic for now just to show everyone so it makes more sense, because the circuit board layout's probably not going to look exactly like this, and for beginners it might be a bit more confusing, so I always like to try and show a schematic now in my videos. I've just decided it's a better thing to do with my projects than just talking about stuff that some people might not know what I'm talking about exactly. But anyway, here's what I've done. I've got we've got our 2 battery stacks, 16.8 volts on each. That's 4 4.2 volt fully charged lithium ion cells. This is the same switch, just like this is the same switch. They're double gang switches. Right, so we have our 0 volt in the middle here, and we have a switch here. It's the same switch. These are our banana jacks at our output. So we've got our 0 volt, and when the switch is, okay, I kind of drew that a little bit wrong. I would have to swap these 2 wires over. So, when this, I don't need to explain this, it's pretty self-explanatory. It's supposed to mean that, when the switch moves up, it connects this to the 5 volts and the plus 5 volts at the same time, and down minus 10 and plus 10 or vice versa. You get what I'm getting at. Now I've put a 3K3 resistor and a green LED across the 20 volts. to provide indication that both the regulators are working and that, you know, it's running, and it's switched on. And I've put a 6K 8 resistor across the 10 volt rail, so that there's still a closed loop for the single 5 volt regulators. So they're always in closed loop. 100 microfarad caps, 100 nanofarad monolithics on the output of the 7805 and the 7905, and for the second output, the 7805 and 7905, but where you've got your 10 volts, 47 mic and 100 nano. How'd that happen? All right. So that's that. That's all there is to it. It's pretty simple. So now what I'm going to do is I'm going to go off and make up a PCB layout. I'm going to use this piece of board actually. I wasn't going to originally, because originally it was just going to be 2 5 volt regulators and a couple of batteries, which is just, you know, that's way too big for it. But now I will use this board because it's actually really good for this case. I've just got a cut. It's the perfect width to slide into one of those gaps. I mean the perfect width. I've just got to cut yay much off of it and it will slide in there. Alright, so I will use that board. That'll sit in the middle perfectly like that. That's actually really good. And obviously, whatever area of the board I don't use, I'll cut off so that I leave space in the back for the charging modules and the batteries. But that way across, because it's the perfect width for those gaps, I've decided to use this board for that. So what I'm going to do now, like I said, is I'm going to draw this up. You know, obviously the batteries and the banana jacks and the switches aren't on the circuit board, right? So I've got to just sort of draw up this circuitry in a layout that goes on a PCB, and then copy that over to this. Clean it up first, obviously. It's already pretty clean, but I'll still give it a clean. And then we'll etch it and assemble it. We'll do all this in this one video because it's just such a simple project. There's just no point. It's not like there's, you know what I mean? It's too simple to make multiple videos. So I'm just going to do it in the one video. I might actually just the PCB etch itself, make a separate video and put that on the PCB etching playlist for people interested in PCB etching. But other than that, this is just going to be one video. So I'm going to go and get on with that now, and I'll be back soon. So it's just come to my attention that I've already messed up something in the schematic and I can't leave it out. I left the diodes out. So my apologies. Okay, sorry about that. The reason the diodes are incredibly important is because we have batteries behind switches. There is no capacitors on the input because, I mean, the batteries are basically like low ESR capacitors already, so there's no point in adding capacitors to the input, right? Now, here's the thing. If even without a circuit on the output, as soon as you turn this switch off, there's still going to be a higher voltage on the output than the input because there's capacitors here 47 mic, 100 mic, 100 mic, 47 plus the 100 nanos. That's going to drain down slowly, and the emitter to base junctions will exceed the whatever 5 or 6 volts usually that they can handle, and that they'll break down. So those diodes are incredibly important for this circuit. Also, you could have something attached to the output that also has capacitors in it, and that could make it even worse. But like I said, without anything on the output, it's already a bad scenario. So those diodes are very important. So I've just added those to the schematic. I'll just have a quick look on the table here. No, there's nothing else. That's everything. So that is the schematic. All right, I'm going to go draw up the circuit board now. I'll be back soon. Okay, so I've converted this, or the part of it that, let's put my pen and eraser, sorry, pencil and eraser. I'll hold on to the pen for pointing. I've converted the part of this that we need on board into this, and I've cut the board down. So we've got this little piece that just you get the point. Incidentally, 1-to-1. This just helps me out for copying it over. So I've left a bit of space. The reason why is each one of these 4 regulators will end up having a heat sink on it. And let me just go grab a heat sink. Show you an idea of what I'm thinking of putting on them, because I want to be able to use it as a power supply too if ever I need, you know, a portable power supply that's 5 or 10 volts dual rail, or, you know, a low noise isolated supply or whatever. So I might want to pull, you know, 1/4 of an amp, 1/2 an amp off of the thing. So you know, normally you get heat sinks like this for TO220 little devices, but you know, they come in all slightly different. That wasn't what I thought it was. Why is it when you're looking for something you can't find it? You know what, I've probably, oh no, here we go. You can get much wider ones like this and everything in between. So the point I'm getting at is I want to put as bigger of a heatsink on each one as what I can. So one's there, one's there, one's there, one's there, one's there. So, you know, even these would almost fit in here. So I'm going to be able to, that's the reason why I've used such a big layout for such a simple circuit. It's purely just to fit the 4 regulators in there with the heat sinking capability, so as to get decent power output out of it. So what I'm going to do now is I'm going to go transfer this onto here, and then I'll come back, etch it up, and we'll get to building. I've got everything ready to build it to make it work. That's why I made that 4th battery clip, so we can just run it off 4 9-volt batteries for now. So yeah, we can literally complete the project just without the charging module, battery management system, and the lithium ion batteries. That'll just have to wait a couple of weeks because I'll have to order them and wait for it to come. Well, I've got the batteries, I just need the charging modules. Actually, I don't know how many of those little cells I've got, and they're not all the same size, so I'll probably order 4 little LiPo cells and the appropriate BMS system for it. Did I say 4? 8. Anyway, you know what I'm trying to say. Yeah, and obviously a USB port for it to charge it. But anyway, that's not applicable right now. So, and the beauty of it is because that's all separate circuitry, like, you know, it doesn't affect this. This just sits in here like this. The power switches will still be wired up to the same spot. they'll just go in between 9-volt batteries or the BMS and batteries, rechargeable batteries when I upgrade it. So the whole front panel on this will just stay the same, and basically this will just come out the back and a rechargeable lot will go in when I get it. So we can literally proceed with building this and give it a test and use it without having to wait for the rechargeable modules and LiPo packs. So that's good. Actually, considering I've got to buy LiPo packs and charging modules, I might have to wait a couple of weeks because I might not be able to buy them just yet. I'll have to see, but yeah. Anyways, I will go get this onto here and I'll be back. Just a quick side note, I have these capacitors. There we go. No. Focus. Really? Can't win. Hold on. God. I really can't get that to focus. There you go. Leave it in the comments if anyone recognizes that. I'll give you a hint. These used to be available from a lot of different places when I was a kid. And yes, they are very old. If you compare the legs on them to some new capacitors that I've got, you'll notice it doesn't really come out on camera, but these are practically grey. They're that old. And these are really shiny. It's more visible from a distance. You see down here as I move them around. Yeah, you can really see it. Leave in the comments if you remember that brand and where you used to get them from when you were, maybe not a kid, but when you were purchasing them. Okay, so I've made up that. So you know the drill now. I'm going to set up the ferric chloride bath and we're going to etch the board. So I'll set up and I'll be back in a moment. I know that's not my neatest work. I just did it by hand. I'm not drilling holes and putting the components through it either. I'm just going to solder it all on top. It's a battery power supply. It's nothing special. So, all right, I'm going to go set up. I'll be back in a moment. I just want to say, sorry about the lighting. I've had this second light over the other side of the room because I've been using it to sort out components, but I've just brought it back over here because I want to be able to let you guys see what I'm doing, give you guys a good view. I'm just going to go warm up the ferric chloride a little bit and get this heat plate warmed up a bit too, and I'll be back. Alright, I've warmed up the board heat, the PCB board heater, the tray's warm, even the board's a little bit warm, and I've warmed up this. By warm I mean, 30, 40 degrees, just, not hot, but not cold. This phenolic PCB seems to float. Okay. I was going to say that looks like it was going to be a bit of a problem. Floating PCBs. Not really what you want when trying to etch a board. Let the process begin. I'll pause the video for a little bit and I'll come back in a bit. I've got some paper towels here ready and some IPA, and I've got a sink in the room next door to wash it off, so we're ready to go. Got all the components laid out here already, as you've all seen. So as soon as this board's done, we're going to make it up. It is actually 11:03 p.m. now, but the only noisy stuff that I've got to do is drill 3 holes in this plastic cover for the banana jacks, and that's not going to make that much noise with a battery drill drilling through plastic. So we're going to get this entire thing done tonight, which is good because I wanted to get it all done today. That way I can start on the amplifier board tomorrow. I'll pause the video for a bit and I'll come back when this has made a little bit of progress. Actually, you know what? This board is actually sort of floating. It's kind of weird. It doesn't completely sync. It's in there enough, you know, but this phenolic PCB does sort of contain a bit of air inside it. I guess the more liquid weight you've got there, like the more liquid mass or height in your tray, the more it's going to hold it down. But still, that poses a bit of a problem, because if you're trying to not use too much at a time, and I mean, like, this is the same lot I've used a few times now, but still, if you're trying to, well, I did add to it for the last board to bring it up to the level it is now, but if you don't want to, you know, have to fill it up too much, those phenolic boards can be a little bit annoying because they float. Well, the process, you see what I mean? The process has begun, so I'm going to pause the video and I'll return soon. My apologies, I've kind of gotten carried away cutting the front out. This is, well, I was going to say almost done, but it's actually still got a little bit to go. Yeah, this solution's getting used up. All good. Alright, we'll be back soon. Well, it's almost done. Just a couple more minutes and that will be done. So will this in a couple of minutes. Well, the board's finished now. So I'm going to go and get this washed off. Incidentally, that's one jack away from being finished. The timing. Alright. I'm going to go and take this into the bathroom. That way I got a porcelain china, whatever you want to call it, sink in there. Going to go wash this off. I'll be back. Forgot to pause the video. Alright, that's the circuit board washed off, ready to clean the marker off of, and I've also made the front panel up. Yeah, I just made it up by eye, but it's not too bad. You can hardly tell. I'm happy. So that's the front panel. So with this, I'm just gonna put one of these down first. I'm just going to cover the tissue and the board in some IPA, a bit of IPA, and just start cleaning it up, scrubbing away. You see why I put the paper towel down. Last time I didn't do that, and then I had to clean the mat, or I don't think I've cleaned it yet. It needs to clean this mat. But yeah, paper towel. All right. These are phenolic boards. The black really rubs off and gets into the edges of the board, I'm noticing. Oh well, not to worry, we have our board. So, population time now. I'll fire up the soldering iron and I'll be back. Alright, I think what I'm going to do is I'm going to upload this video now and then instantly start assembling this, because it's basically like a kit, and it's going to be like a what do you call it, like a kit build sort of video. So it'll be a separate video, and then for those people that like watching stuff getting built, they can watch the assembly. That's the word I was looking for. One thing I do want to point out, these regulators, especially the 7905s, sometimes have the ground and input pin swapped around, and in my case it turns out that they did, which is really annoying because it means I've got to twist that leg and that leg sort of to the opposite spots. If you're trying to make this at home, basically where the 7905s go, you need to swap this and this around, these two. So you would need to run a track sort of going like that and a track going like that, so that this is connected to this pin and this is connected to this pin. It's just a small modification. You just have to go bang, 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 if that makes sense. So yeah, very small modification, but I screwed up. I'm going to have to bend the legs. I thought I'd make this look interesting too. So what I'm going to do is I'm just going to solder the components on the board, but I'm not going to tin the copper. I'm going to cover it with lacquer spray afterwards so that it's got an interesting look to it. And as far as wiring it up goes, I have literally got every single color of wire here. So the reason I thought I'd make it look like colorful and interesting inside is because it's got clear panels. You can see inside it, so I want it to look interesting. But yeah, that's it. I'm now going to build this, so I'll sign off on this video and I'll see you all in the next one.